Hello guys, so how are you? So today we are solving this problem extra character in a string. So basically one string is given to us like in this example. See here we are given a zero indexed string s. Okay, for example this s is given to us, LeetCode, and one dictionary is given to us. This dictionary has multiple strings inside it. So now what we have to do is uh, we have to break the s into one or more non-overlapping in the sense it should not be like you split it like leads and then tscode, means everything should be separated only. So it should be like let's say if we are having some word like abc. Okay, so we can split it like ab and c or a and bc, right? But we cannot split it like this, that we are having AB plus BC, right? We cannot have this way because there B is overlapping, right? So nothing should be overlapping. It should be like A and BC, B yeah, otherwise it should be like AB and C. Okay, so no overlapping. Like this case, this is an overlapping, so this is not allowed. So what we have to do is basically after splitting into the non-overlapping, we have to check whether whatever split string we have done, that should be also available in the dictionary. So this is first condition. It should be non-overlapping split, and whatever word we are getting after making the split, those words should be available in this dictionary. Now if we find all those combinations, we have to find the combination which is having the extra characters as minimum number of extra characters. So let's take one example which will make a better sense here. Suppose we have a string like this. A string means this string. Okay, I am impact and fully. Okay, this is our string and this is our dictionary. Dictionary has I word, it has impact word, it has act word, it has fully words. Now we have to break this string in such a way that the words should be available in the dictionary. So for example, we can make it like this. We can split like I and act and fully, right? So we are picking this guy first character. Okay, then we pick this act and fully fully. So all those three are available in the dictionary. You can see here I is here, act is here, and fully is also here. So this is a one of the valid split. Now we have to check how many words we are skipping here. Okay, so we have skipped m, right? Because we are not using m anywhere. Similarly, we have also skipped p, right? M and p is skipped. And similarly, we have skipped this guy n as well. So how many total? 2 characters here, mp, and 1 n we missed. So total 3 characters. So we are missing here total 3 characters. So for this particular split, we are getting the 3 missed skipped character, right? Now we can split in some more thing, right? We can also split it like this: impact and fully, correct? Because impact is available in our dictionary, it is residing here, and fully is also full. Yeah, so see here, this is impact and this is full. So yeah, sorry, this one fully. So both of them are available in the dictionary. That means this is a valid split. Impact is available, fully is also available. But what is the missing here? We have missed only the n here. Impact, fully, so n is missing here. So how many we have missed here? We have missed only one, right? Only one character we are missing here. So what is the missing count here? Missing count here is 1. Okay, so far this would be rejected because we are looking for the minimum missing split. So far this is our 1 is our answer. Now we'll go further. So let's say I am splitting it impact plus full. So impact is available there in the dictionary, but full is not available in the dictionary. See here we have I, then impact, then act, and then fully. So this is not a valid string split at all. So we will not consider these kind of cases. So here whatever is the valid combination and whoever is producing the smallest missing characters, that would be basically our answer. So in this case 1 is our answer. So this is what we have to do. Now next thing is how to do this. Okay, so let's understand before going to any dynamic programming or recursion. Let's go for the intuition that how to think that we have to go for recursive or then DP. Okay, so consider in general, let's say I'm calling a string as str. Okay, now you can see here, see we don't have any grid approach here because anything could be valid starting from any point, right? So nothing is going in a grid way. Okay, so then what to do? So basically what happens, every time, see here we picked I, right? But if I don't pick, so there could be possibilities. We can have any string, it's not only about this string. So we don't know that which one would be lead to best solution. That means we should start from all the indexes, right? So maybe we are taking very first, let's say our start is 0. Okay, so we can have any index but say start. Okay, so if let's say we are starting at 0 or we are not starting at 0, so if we are not starting at 0, that means we are picking to the next character 0 plus 1, right? And similarly then after picking that, whether let's say we are picking the start one. Okay, so if we are picking the start one, that means we would be starting from 0. Now in starting from 0, we have to traverse till the time we will get a valid string which is available in the this dictionary. For example, in case of impactfully, we will start from here. So IMPACTFULLY. So when we will reach till here impact. Okay, so at the impact we can check that yeah, this is available in the dictionary. See here, impact is available in the dictionary. Even I was available at the dictionary, right? So first reach would be when we are starting at 0 and ending at 0, right? So we will finding I here, right? But we have to check all the condition. Let's say at ending at 0, we got one string which is also available in the dictionary. So this is one of the right word. Now similarly we can check for is there further values, right? So staying at 0 is one thing, but we have to keep on going, right? We have to check for is there some more thing when we are starting from 0 itself, is there some more string which are also available. So for example, impact is also available, correct? So in this way we can have multiple combinations. So this gives us one intuition that we can go for the recursive approach. Because why recursive approach? That once we found a string in the our dictionary, then we have to go for the remaining string, right? So similarly we have to call same function on the remaining string as well. So this gives an indication that we can write a recursive approach first. Okay, we should not go directly to dynamic programming, because recursive is the first intuition which leads us to the dynamic programming. Okay, so let's write the recursive function for this. So guys, as we know that every recursion function should have a what? Every recursion should have a closing condition, right? So let's say we are starting for string str, suppose. Okay, and our start point, let's say we are calling it start, strt. This is our start point. Now see here, so suppose I have the n is the length of this string. Okay, then what happens if start and end are same? That means we are starting at any particular index and ending as well there only, like single like in this case I, right? So when I is starting at 0 and ending also at 0. So whenever we are passing something in the recursion where start is also equal to n, right? Basically the length of it, whatever the length of this string. So in this case what happens, this gives an indication that everything is already covered. We have the strings from 0 to n minus 1, right? The string index would be 0 to n minus 1. And now if we are calling on a function strt start point which is equal to n, that means everything is already covered. So what will happen? We will return here what? We will return here 0, because nothing would be left, everything would be done, correct? So we'll be returning here 0. So this is now our closing condition. Now what we will do is we will have two options. Either we are starting from this guy strt, or we are not picking, because we already indicated that we have the approach of picking or not picking, right? So let's say for start, first of all we are starting with not picking. Okay, then what we will happen, let's say we are making an answer variable. So answer, when we are not picking the start, what would be the answer? It would be like a recursion of, if we are not picking at start, that means we would be picking it on the next value, right? So what I am doing here, start plus 1 I am making it, right? strt plus 1, because we have skipped the first character. Okay, and what I'm gonna do here is, after making this guy for start plus 1, I am making plus 1. Why I am making plus 1? Because we are finding the total number of skipped character, and in this case, not pick case, what we are doing, not pick case, we are basically skipping the index start, right? So this is one thing when we are not picking. Now we are looking for the picking. Okay, when we are actually picking it. Okay, so when we are picking, what it would be? So first of all, what we have to do is, let's say when we are picking, that means we are starting at the very first location, basically that start index, right? So we have to check that up to what index we are getting a valid string. Valid string means somebody which is residing at the dictionary. So it could be from start, let's say I'm calling the end point. Okay, from end means basically where a valid string is ending. Okay, so from end equal to start to, I am making here start also, because a valid string could be ending at the start itself. Like here start is 0, but a valid string is at 0 ending as well, because we have I as a valid, because it is residing in the dictionary. Okay, so here what I will do is, I will make this again this function. So for int end equal to start till what, till end equal to less than n. Okay, because n is the last n minus 1 would be the ending character where we can end our thing, right? And then we would make this end plus plus. Okay, so this would be the end where we can check for the substrings. I am calling right now as a substring. Okay, so now what we will do, we will check that if our dictionary, if this dictionary contains this value, what if dictionary contains the value which is starting at the strt, okay, which is starting at the strt and ending at the end, and whatever value it could be, right? So now here what we are doing is, we are getting basically the substring which is starting at strt and ending at end in this for loop, right? So if it exists in the dictionary, okay, if it exists in the dictionary, that means this would be a valid string. Okay, so if we if it exists in the dictionary, what we can do is, for example, here I exist in the dictionary. Okay, so we would have this remaining string. So for this remaining string also we have to call the same function. Okay, so but we need to find the minimum value. Okay, so what we will do, we already calculated without picking it. So what we will do, we have to return what? We have to return the first of all we have to make the answer equal to, so let me remove this return. So answer equal to math.min of, okay, min of answer and what? Answer and the same recursion function for this remaining string. So we are calling again this recursion function with the remaining string. So what is the remaining string? Remaining string is starting at end plus 1. Okay, end plus 1. Okay, so its start point is now end plus 1, and same other parameters we will put as it is. Okay, so this is what our recursive approach is, and finally we would be returning the answer. Okay, so return answer. So this is plain recursive approach. I didn't use even the memoization. So far this should be very clear. Now the question is, if we go with the recursive approach, basically there would be lot of overlapping subproblems. Overlapping subproblem means there would be lot of same substring which might be possible, where we are again and again calling our recursive function. This will eat lot of CPU and this would be very high in the time complexity. So for that reason, what we do, we will make a array. Okay, basically we will do the memoization. Okay, so we will make an array of size n of integer type. Okay, and you know that here we are dealing with the start point. Okay, so every start point we are finding that what would be the answer. So basically we can store dp for any index. Okay, we can store the sub problem solution. Okay, dp start equal to whatever answer comes. So basically wherever we are getting the answer, we can also assign right after it, we can also assign this, like we were doing the return answer, right? So we can do what? So here we can basically in this dynamic array, so dp array, we would be storing this answer and we would be returning it. So now we are overcome with the overlapping sub problem, but now we will look for the, to avoid the recursion stack deepness, we have to avoid this kind of solution. So we will look for the dynamic programming, because still it's a recursion which will go deeper and deeper in internally, having a deeper in stack. So we should look for the production ready code which would be come from the dynamic programming. Okay, so we will use same concept over there. So guys, for example, we are going for this string impactfully and same that dictionary. So whatever the length of this string, okay, we will create a dynamic table of n plus 1. So why n plus 1 is, like we can have the length from 0 till whatever n. So 0 till 12 length we could have. So for that reason we have to create n plus 1 size table, right? So you can call it dp table of n plus 1 size. Okay, now we have few things, like in the recursion we had the closing condition, right? That if start equal to n, we were making it returning the 0. Okay, so same thing, same kind of concept we will be using here as well. So see here, this is 12, right? So if start equal to 12, that means its index itself already till n minus 1, right? This can go only till 11, right? So starting from 0, this can go to only till 11. So here what it should be? It should be 0, right? Because we are out of the things, right? Just like in recursion we were doing, if start equal to n. So same condition is approaching here. So I am putting directly here 0. Okay. Now I am going in bottom up way. Okay. So see here, this is my last location, right? So what would be the answer to fill this guy, right? So in recursion what we were doing? In recursion we were doing that that thing, right? We were doing answer equal to math.min of whatever answer we had and the recursion of that start plus 1, right? We were doing that recursion of start plus 1. This way we were doing that. So same way we have to use here as well. Okay, so see here, this is our first valid location, right? Last valid location. So here what we are doing, I am using one for loop which is starting at n minus 1 and coming till here 0, right? So greater than or equal to 0, then I am making start minus. This is a bottom up approach. You can do the top down approach as well. Okay, not a problem. So using this for loop, what we are doing, we are encountering every time the start point, right? Now see here, how would we reach till this start point? So see here, what I am doing is dp of start equal to dp of start plus 1 plus 1. You remember when we were skipping the start in recursion? So just instead of recursive function, we are putting this dp. Okay, you can consider in this simple way, dp of start equal to dp of start plus 1 plus 1. We were skipping the start character when. Okay, so that is why we made this plus 1. So this is one thing. Now other point was to not pick. This is the pick case. This is not pick case, np case, not pick. Then we will make the pick case as well. So when do we pick any string? When it is valid, when it is inside our dictionary, right? So again we will check that what all values could be there. So we would be checking for those inputs. So that was the not pick case. Now in pick case, what will be happen? Our string might be ending at the start, so it would be ending at start till it can end at what would be the last location? It could be going till the this thing and the length of it, right? So now we have to look for the substrings, right? So what would be the substring in this case? So for understanding purpose, now consider substring. Otherwise, dictionary we will basically convert into the trie data structure, which makes it a bit faster. So now from start to end, when we are picking, we have to make the start and end. Whatever start and whatever end, we will have a one string, right? Now whatever string this str string is being generated, this string we have to check whether this guy is available or not in the dictionary. If it is available in the dictionary, then that means it could be a valid thing. So if we pick that particular thing, then we have to call to the left, whatever is the left in the right side of that string. So same fundamental would be used here as well. We'll do here now. We will do one thing, that dp of start. Okay, when we were doing for answer, right? So same way we will do in dp also. So dp of start would be math dot min of dp dot start comma what? So this would be dp dot start and whatever value so far checked for the other indexes, right? So we were doing all together. So first of all, we have to check before this whether this is valid. Valid means it is available in the dictionary. Okay, so after doing the validation checking, then we'll make this dp start is equal to min of dp and min of dp and plus 1, right? Because our next string would be starting from end plus 1 character, right? So dp of end plus 1. So whoever, now we are partially filling all the values, right? Our entire dp table would be filled. Once we are done with this, what we have to do? We have to return the value residing at 0, because this is the place where our whole string is starting. Our whole string is starting at 0, right? Impactfully. So what we have to return finally? We have to return dp of 0. This would have our answer, because we are dealing for the starting point, that from, if it is starting from here, what would be the value? So we started from here, we did the partial value for here, we did partial value, we filled partial value here, so on, keep on, and then we came to this condition, right? So this is what we have to do. For example, here we would have initially we filled 0 here, then we would be starting from here. This is our end n minus 1, right? So ending at n minus 1. So y doesn't exist in this our dictionary. Our dictionary has, right, I and impact and fully. 3 words were there, right? I and impact and fully, fully, right? So if we go here, see, we started here, so y is not available, then we will go here, ly is not available, lly is also not available, this is also not available, but here fully, this is available, right? So when this is available, we will go to this index, okay, and we have, this is our rest of the string. So then we will look for this the particular solution for this value, and similarly we have to look for by skipping as well. Okay, so this is what the basic idea is. I will show you my code, what is actually happening over here. So guys, one simple thing is, like, I created one trie. Okay, you can read about trie data structure, because if we store the this thing dictionary in a set, then we are going then substring way, right? And creating substring is a costly, so that is why we are storing the dictionary in the trie. Okay, so trie is nothing like, it has like a class which map has the character and another trie into it. So basically this is an efficient way of storing the strings, and wherever a string ends, like let's say we have a b c d, suppose this is our string, okay, but abc is available in the dictionary, then what will happen? A at this node, at c node, this is end would be true, Okay, because true indicates that yeah, this is the end of some word. Okay, so this is the simple concept you can read about trie. Okay, so I am storing the dictionary in the trie. Now what will happen next is, so at this step what I am doing is, this is just counting the n, and see here I am building the trie. Okay, make trie, there's one method, will explain that. So this would be having like you can consider now root is our basically the dictionary. Now if I'm creating the dp table of n minus 1. Now see here we started from very last location, right? We started from here, right? N minus 1. Same thing I'm doing here, and we will going till the 0. Then see here when we are not picking, so dp start is equal to dp start plus 1. We added 1 because we are not picking the start index. Okay, then what we are doing is, we are going for the starting from the start till the end. Okay, so this will give us all the substring values, right? So we are not directly calculating the substring here, we are just checking in the trie. This is our trie, right? So every trie had children, and in that children we are checking whether this character existing or not. Okay, so in the trie we can go to character by character. Okay, so see here, if whenever we are finding that node dot is end, so whatever character we found, okay, in this range, if is end is true, right? Is end is true means that is a word. So if this is a word, that means we found one word in the dictionary. Okay, so now what we are doing here is, that means this is a valid word. So the validation checked here, then we are fulfilling this dp start is equal to math.min of dp start and dp end plus 1, same way the way which we were doing here. Okay, so now finally our dp would be filled, and we have to return the dp of 0 because we are starting, our string is starting at 0. See here at this location what we were doing, we were fulfilling our dp start, right? If our dp start was math.min of dp start, whatever we calculated here, we have to look for the minimum value of dp start and dp of end plus 1, right? Because end plus 1 is the place where we are looking for the rest of the this character thing, right? Rest of the string that is starting at end plus 1. So same thing we were doing in our code. See here, and then we are finally returning at dp0. See here I am returning my answer at dp0 because our string is starting at 0. And this is simple method make string, which is what is actually doing. It is taking the dictionary array of strings and taking each of the just made one node of this trie node. We made one trie node to store those values, and see here what we are doing, we are taking every value of it and we are inserting it into our trie. And see here, whenever a word is completed, we are making that node dot is end equal to true. Okay, this indicates that yeah, something is ended here. This is by default here false, but it would if is end equal to true means that the word is ending at that particular character. So this is this part is just building the dictionary into a trie, storing all those values into trie, because searching in tries are way faster and we don't have to find the substrings if we go for the dictionary inside a set. Okay, so this is all what we have to do. Let me execute this code. It is working fine. Let me try to submit it. Yeah, it is accepted, 90.14% faster. So thank you for watching this video. If you guys have any concern, please make a comment over there. Thank you.